For today's lesson, graphing a linear equation in slope-intercept form, we only have one learning target, and that is I can graph a linear equation using its slope-intercept form y equals mx plus b. See, what if you are asked to graph the equation y is equal to 2x plus 3 by plotting points? Okay, so how will you determine the points? And how many points are needed? To determine the points, we are going to look for coordinates which are solutions to the equation. Okay? So, how are you going to do that? We need to look at the prepared coordinate plane on the possible values of x that we can use. Okay? So, obviously here we can just make use of negative 3, negative 2, negative 1, 0, 1, 2, and 3 as the values of x. Now, technique. In graphing, use smaller values of x so that in the computation, you'll not find difficulty. Okay? Now, why do we need to, what is the advantage of having the equation in this form? Okay, the advantage is the equation is already solved for y. So, all you have to do is substitute the values of x. Next question. How many points are needed to graph the line? So, we need at least 2 points. Pag sinabing at least 2 points, minimum of 2 points. Okay? So, let's start now. Start determining the points whose coordinates are solutions to the equation. So, let's choose smaller values of x. We have negative 1, 0, and 1. So, we'll have, okay, x is equal to, if x is equal to negative 1, x is equal to 0. When x equals 0, that is our y-intercept, remember? Then we have x equals 1. Let us solve. So, if you are not an expert in the substitution process, then rewrite the equation. Y is equal to 2x plus 3. So, you have y is equal to, substitute the value of x. Our x is negative 1 plus 3. So, we have 2 times negative 1 is negative 2 plus 3, it is positive 1. So, the first point rather, has coordinates negative 1, positive 1. Okay, negative 1, positive 1. Next, for the second value of x, that is 0, so you have y is equal to 2x plus 3. Y is equal to 2 times 0 plus 3. We have y is equal to 2 times 0 is 0, so we have y equals 3. So the second point has coordinates 0 and positive 3. 0 and 3. Next, we have, if x equals 1, so we have y is equal to 2 times 1 plus 3. So we have 2 times 1 is 2 plus 3 equals 5. Okay, so we have the third point has coordinates. We have 1 and 5. So you have 1, 5. Let us now plot the points on the rectangular coordinate plane. So we have the first point has coordinates negative 1, positive 1. Okay. Then we have 0 and 3. Then we have 1, then 5. Okay, let us now connect the points. And then for step 3, draw the line through the 3 points and extend the line and put arrows on both ends. Now, why do we need to put arrows on both ends? The arrows will indicate that the line will be extended up to infinity, and that only means that this line has infinitely many points, infinitely many solutions. We just identified here 3 of its solutions or 3 of its points just to graph it. Did you understand now? I hope so. So for your practice, kindly open your book on page 15. Answer items A and C. Okay? So you are guided here. Then for item C, choose values of x that are multiples of the denominator, such as 2, 4, and 6, etc., so that you'll not find difficulty in performing division here, or will not be dealing with fractional x fractional x coordinate, and at the same time a fractional an ordered pair which contains a fraction, because it's quite difficult to plot it. Okay, so pause this video for a while so that you'll have some time to answer these items. Then after answering, play the video again to view the answer and check your own work. Okay, pause it now. Now let us check item A. Okay, so you have the following steps. Okay. Now looking at the prepared coordinate plane, you are only limited to what values of x, -3, -2, -1, 0, 1, 2, 3. Okay? And what was the technique I taught you a while ago? Use smaller values of x. So -2, -1, 0, and 1 could be the most practical values for x. Okay? So, but we can still make use of -2 and 2. Okay. Say if we are going to make use of the 5 points here, so that we can see that these points, even if you have many points, they all lie on the same line. Say we have here, let's start with um, x equals -2. We have x equals -2. We have y is equal to -2 times our x is -2. Do not forget to add 1. We have y is equal to -2 times -2 is +4 plus 1. Y is equal to +5. Then we have if x equals -1, we have y is equal to -2 times -1. Do not forget 1 plus 1 here. So we have y is equal to -2 times -1. It's +2 plus 1. So y is equal to 3. And if our x equals 0, we have y is equal to -2 times 0 plus 1. So we have -2 times 0 is 0. So what's left is 1. Then if our x is equal to +1, okay, we have y is equal to -2 times 1 plus 1. So we have -2 times 1 is -2 plus 1, it's -1. Then lastly, if we have x equals +2, then we have y is equal to -2 times 2 plus 1. So we have -4 plus 1. Y is equal to -3. So let's organize the points here in the table of values. So we have um, when x equals -2, our y is 5. So you have -2, 5 here as the ordered pair. Then we have x -1. We have y is 3. Then we have x is 0. Then we have 1. Then 0, 0, 1. And then we have the two added points here. When x equals 1, then we have our y is also 1. And the last point, we have when x equals 2, then we have y equals -3. 2, -3. Let's plot these points in the coordinate plane. We have -2, +5. Okay, we cannot see negative. Okay, +5 rather. So it's +5 is found here. So it's found on the second quadrant. Then we have -1, +3. Then we have 0, 1. Then we have 1 and 1. 1, 1. What happened to this? Okay. 0, 1. When x is equal to 1, it's negative 1. Okay. So 1, then we have negative 1 here. Then we have 2, negative 3. 2, negative 3. Look at that. Okay? If you're going to connect them, okay, they are really aligned. Okay, connect 2 points every 2 points. Okay. And then we're going to draw the arrowheads that would indicate that there are plenty of or infinitely many points or solutions on this line. So this is now the graph of y is equal to negative 2x plus 1. I hope you got it correctly. Next is item number 2 with equation y is equal to x over 2 plus 3. Again, the hint is you're going to choose the values of x that are multiples of 2. So let's consider the prepared coordinate plane. In the coordinate plane, we only have negative 2 and positive 2, which are multiples of course, of itself, 2. Okay? Then we can include 0. So we have now when x is equal to negative 2, when x is equal to 0, when x is equal to positive 2. So, let's substitute. We have y is equal to x. X is negative 2 over 2 plus 3. So, we have negative 2 divided by 2 is negative 1 plus 3. So, we have positive 2. So, when x equals negative 2, our y is positive 2. The next is we have x equals 0. So, we have y is equal to 0 over 2 plus 2. So, our y-intercept is what? Point 2 with coordinate 2 rather. So, we have y when x is equal to 0, our y is 2. 0, 2. Our y-intercept is at point 0, 2. Then, lastly, we have this point. Y is equal to, our x is 2 divided by 2 plus 3. We have y is equal to 1 plus 3, y is equal to 4. Okay, so the last point has coordinates 2 and 4. Okay, let's plot these points in this coordinate plane. So we have when x equals negative 2, y is positive 2. And when x equals 0, our y is 2. And then, 2 at saka 4. 2 and 4. So what happened to this? Okay. Something is wrong here. Okay. This must be plus 3. Okay, that's why. So this must be positive 3. Sorry for that. So this is plus 3. Okay. We can really check if our answer is wrong if the points will not be aligned. Okay. So let's erase this one. Let's check this. Okay. So we have it's plus 3, so 0, 3. And this becomes 3. And this is 3. So we have, okay. So you have second point 0, 3. Okay, now they are aligned. Okay, connect the 3 points. Okay, let's make it clear. Okay. Okay, so I'm going to connect them again. Okay, it's clear now. Extend the line, then not forget to draw the arrowheads that would indicate that the line can be extended up to infinity. Okay, I hope you got the answer for this item correctly also. Now for checking and recording, you're going to answer activity number 4, independent practice on page 17. Do not forget to upload this one in our LMS. Okay, now let us go back to our learning target. Reflect on this. Okay? I can graph a linear equation using its slope-intercept form y is equal to mx plus b. If your answer is yes, you can confidently graph a linear equation using its slope-intercept form, then congratulations. If not, again, replay this video and try the skills practice again. So thank you for watching. See you in our next lesson.